particle nature of matter. If you still haven't watched the previous lesson, you can pause this video and watch that one first to better understand our lesson today. Let's get started. Matter undergoes either physical or chemical change. Physical change is a change in one or more physical properties of matter without changing its chemical properties. Examples of physical change include changes in the size or shape of matter, like when you fold a piece of paper to origami art. Changes of state, from solid to liquid or from liquid to gas, are also examples of a physical change. Chemical change occurs when a substance is transformed into another substance, like when you burn a piece of paper. Most substances can exist in three phases, depending on the temperature and atmospheric pressure. Some substances, like water, can exist in all three phases at ordinary conditions. When heat energy is absorbed, also referred to as endothermic, or released or exothermic from a system, one phase can change to another. Change in the energy of a system can cause the particles to move faster or slower, resulting in changes in the arrangement and attractive forces existing among molecules. Phase change is a process of changing from one physical state of matter to another. Phase changes are physical changes because it only affects physical appearance, not chemical makeup. Like most substances, water can exist in three distinct states, namely solid, liquid, or gas. For example, when ice melts, it undergoes a change from solid to liquid. When water boils, steam is formed, and this signals a change of phase from liquid to gas. At certain temperatures, water changes from one state to another. The water molecule contains two hydrogen atoms and one oxygen atom covalently bonded. However, there is no change in the composition of water. The particles that make up ice, water, and steam will contain two atoms of hydrogen and one atom of oxygen. A phase change is just one type of physical change. Temperature is related to molecular or atomic motion because when the heat increases, it makes the molecules move faster. And when the temperature decreases, the motion also decreases in the atoms. Molecular motion determines which phase of matter is observed. Slow-moving molecules may be found in solids, while rapid-moving molecules are present in gases. Liquids have molecules in motion that are slower than gases, but much more rapid than those of a solid. During a phase change, heat energy is either absorbed or released. Heat energy is released as molecules slow down and move closer together. Heat energy is absorbed as molecules speed up and expand. If pressure is constant, the state of a substance will depend entirely on the temperature it is exposed to. For this reason, ice melts if taken out of a freezer, and water boils out of a pot if left at too high a temperature for too long. Temperature is merely a measurement of the amount of heat energy present in the surroundings. When a substance is placed in surroundings of a different temperature, heat is exchanged between the substance and the surroundings, causing both to achieve an equilibrium temperature. This figure shows the melting and freezing of water. As you can see, water is still in its solid state and the water molecules are close to each other. The water molecules move very slow. The energy needed for a substance to change the state is latent heat. As it absorbs latent heat, the kinetic energy of water molecules increases, so they vibrate and move faster. At some point, they have enough energy to overcome the forces that hold them in their fixed places, so they break away from their fixed positions in the solid. The arrangement of water molecules in ice gradually becomes disorganized and the ice turns to liquid water. In this phenomenon, as water absorbs heat from the surroundings become cooler. On the other hand, when the liquid water releases its latent heat to the surroundings, the water molecules start to slow down and they become closer to each other. As they become closer to each other, the attraction between molecules becomes stronger and start turning to solid water, also known as ice. This figure shows the change of liquid water to water vapor and vice versa. In the same way, when liquid water absorbs latent heat from the surroundings, the water molecules start to move faster and at some point have enough energy to overcome the attraction between them. As they overcome the bond between water molecules, the molecules move faster and turn into gas, or what we call water vapor. In contrary, when water releases the latent heat to the surroundings, the gas molecules move slower, causing them to become closer to each other, creating more attraction between molecules and turning the gas into liquid water. When an ice cube is exposed to heat, its water molecules absorb heat energy from the surrounding atmosphere. Thus, it is endothermic. As the water molecules begin to move more energetically, the solid ice cube melts into liquid water. When an ice cube melts, its shape changes and it acquires the ability to flow, but its composition does not change. Melting is an example of a physical change. Though its physical properties change, molecules stay the same. The temperature at which ice melts is 0 degrees Celsius. Freezing